Okay, this is the third section for contemporary math for week 1, and we're going to be extending unit systems and unit analysis that we started in the last section. So there's a lot of charts in this section in the book. On page 89 is the United States Customary System, abbreviated to USCS. And then page 91 has some common metric prefixes. And page 93 is the customary system to metric conversions. So the first thing we're going to talk about, and this chart is also in the book, is standardized temperature units. So we have the Fahrenheit scale, the Celsius scale, and the Kelvin. The Kelvin scale is used in science. The Fahrenheit scale, as you know, is used in the United States, and literally the rest of the world uses Celsius. So if you look at, let's start with 0 degrees. This is where water freezes, and water freezes at 32 degrees Fahrenheit. Water boils at 100 degrees Celsius to 12 Fahrenheit. And then this, on the Kelvin scale, this is absolute 0, which is the coldest possible temperature. And as you can see, Fahrenheit, absolute 0 is negative, almost negative 460 degrees. That's pretty cold. So here are some temperature conversions. If you want to go from Celsius to Fahrenheit, the Fahrenheit scale would be, you take the Celsius degree, multiply by 1.8, and add 32 to it. If you're going the other way, you have the Fahrenheit temperature and you want to turn it to Celsius, you subtract 32 from the Fahrenheit degree and divide it by 1.8. And then the Celsius to Kelvin and Kelvin to Celsius, Kelvin is you just add 273.15 to the Celsius, and if you're going the other way, Celsius is equal to the Kelvin minus 273.15. I don't expect you to memorize those, so make sure those are in your notes. And then in this section, we're going to talk about energy and power. So energy is what makes matter move or heat up, and the international metric unit of energy is the joule. Power is the rate at which energy is used. The international metric unit of power is the watt. And 1 watt equals 1 joule per second. So just as an example problem, on utility bills, electrical energy is usually measured in units of kilowatt hours. Remember that the hyphen implies multiplication. And I know that a kilowatt, because of this prefix, means 1,000 watts, which is 1,000 joules per second. So 1 kilowatt hour, this is how we would do the conversion to find how many joules is in a kilowatt hour. So 1,000 joules per second in a kilowatt times 1 hour times 60 minutes over 1 hour times 60 seconds over 1 minute. And remember, we arrange these so that I can cross off these units. Minutes, minutes. So now we're going to take 1,000 times 60 times 60. And that gives us 3,600,000 joules. So 1 kilowatt hour equals 3.6 million joules. And then the other thing that's discussed in this section is density and concentration. So density is generally used to describe compactness or crowding, and concentration is generally used to describe the amount of one substance that is mixed with another. For example, The concentration of air pollutants is usually discussed as parts per million. That's what ppm stands for. Medicine doses is another example of concentration. It's usually based on the recommended concentration per kilogram of body weight. Blood alcohol content is the concentration of alcohol in a person's body, and it's usually measured in units of grams per 100 milliliters of blood. In the United States, a driver is generally considered legally intoxicated if their blood alcohol content is at or above 0.08 grams of alcohol per 100 milliliters of blood. And this is how it's written. So we're going to do an example of blood alcohol content. And this is straight out of the book. An average sized man has about 5 liters of blood, which is 5,000 milliliters. Remember, milli means 1,000. And an average 12-ounce can of beer contains about 15 grams of alcohol. This is based on beer that's like 6%. If all the alcohol were immediately absorbed into the bloodstream, what blood alcohol content would we find in an average sized man who quickly drank a single can of beer? How much beer would make him legally intoxicated? So we want to find the man's blood alcohol content. And remember, this is the amount of alcohol in the can of beer, and this is how much blood he has. And if we do the division problem, we would get 0.003 grams per milliliter. But remember, blood alcohol content is per 100 milliliters, so we're going to multiply this fraction by 100 over 100 to find the concentration in grams per 100 milliliters. And when we do that, we get 0.3 grams of alcohol per 100 milliliters of blood. Well, this is almost 4 times the legal limit. In reality, though, the blood alcohol content wouldn't be this high from a single can of beer because the alcohol is not immediately absorbed into the bloodstream. Metabolic processes gradually eliminate the alcohol at a rate of 10 to 15 grams an hour. And it also, I guess I just want you to think about, this is something I discussed with the in-class kids, that, you know, if you drink a beer an hour, your metabolic process of your body is going to take care of the alcohol in your bloodstream. But as we all know, teenagers especially, at parties where there's alcohol, generally don't drink just 1 can of beer an hour. So that just gives you guys something to think about. Don't drink and drive. And the assignment is to complete the quick quiz 2B, which is on page 101. And that's it for this first week.